Researchers typically begin descriptive work by doing univariate analysis, focusing on one variable at a time, examining its distribution, typical values, and variation. For instance, a researcher may ask what the average depression score is, how stress scores are distributed, or how many students identify as first-generation college students. Bivariate analysis, in contrast, examines the relationship between two variables. It may look at how depression relates to stress, for instance. Univariate analysis is about description and context, while bivariate analysis begins to explore association. Both are descriptive in nature, but they differ in complexity and purpose. This lecture emphasizes univariate statistics. We will explore bivariate statistics in the next lecture. Frequency distributions are among the most common and informative descriptive tools used in social research, especially for categorical survey data. They display how many respondents selected each response option, often accompanied by percentages and valid percentages. Before calculating averages or conducting statistical tests, researchers examine these frequency tables to identify dominant patterns. For example, researchers can quickly see which responses are most common and whether extreme responses are rare or prevalent. Frequency distributions also highlight missing data, reminding researchers to consider whether non-response could bias results. Importantly, these tables encourage evidence-based reasoning. Although a single frequency table cannot answer every research question, it often provides the first clues that shape subsequent analysis. Comparing multiple survey items that measure similar concepts allows researchers to deepen their understanding of the data. The chapter presents a second depression-related question, asking how often students felt they could not get going. For example, while only a small minority of students report experiencing severe symptoms almost all of the time, a larger group reports occasional difficulties. Researchers must also make analytic decisions about whether to combine response categories or focus on extreme values. For instance, combining the frequently and almost all of the time categories yields higher prevalence of depressive symptoms than focusing only on the most extreme category. These choices can meaningfully affect interpretations and must be made transparently. Understanding how much individuals differ from one another is a central goal of descriptive statistics. Measures of variation address this goal by describing the spread of values in a dataset. The minimum and maximum identify the smallest and largest observed values, while the range summarizes the distance between them. To better capture where most observations fall, researchers use quartiles, which divide ordered data into 4 equal parts. The interquartile range, IQR, defined as the distance between the first and third quartiles, represents the middle 50% of observations. Because it is less affected by extreme scores, the IQR often provides a more stable and informative measure of variation. Remember that each depression item is scored from 1 to 4, producing a range of 3. When 2 items are combined, the possible scores expand from 2 to 8, producing a range of 6. When all 11 items are combined into a depression scale, scores can range from 11 to 44, producing a range of 33. We will focus on scale development later in the lecture. For now, it is just important to understand the concept of range. Measures of central tendency summarize a distribution by identifying its typical or central value. The mode identifies the most frequently occurring value, making it useful for categorical data or identifying common scores. The median represents the middle value when data are ordered, dividing the sample into 2 equal halves and providing resistance to extreme values. The mean, calculated as the arithmetic average, incorporates information from every observation and is therefore the most commonly reported measure in social science research. Comparing these 3 measures offers insight into the shape of a distribution. When the mean, median, and mode are similar, the distribution is likely balanced. Substantial differences among them may signal skewness or outliers. In the depression scale example, the close alignment of these measures suggests a relatively symmetrical distribution. Understanding how and when to use each measure equips students to interpret descriptive results accurately and to anticipate how data characteristics influence statistical conclusions. You can calculate the mean, median, and mode on your own, or you can ask a program like Excel to do it for you. The table in this slide provides the formula for producing the mean, median, and mode in the Excel program. As we reviewed earlier, to measure complex concepts such as depression, researchers often combine multiple related survey items into a single scale. A scale is created by simply adding together responses to several related survey questions into a single measure. The simplest way to create a scale is to add the individual responses together. In our example, we add the responses to all 11 depression items. Because each question is scored from 1 to 4, the lowest possible total score is 11%, while the highest possible score is 44%. Higher scores indicate higher levels of depressive symptoms. This approach increases variation and improves measurement reliability compared to relying on a single question. Researchers may report either the total score or the average score, both of which convey identical information on different scales. Scale construction demonstrates how descriptive statistics connect measurement, theory, and interpretation in applied research. Histograms are tools for visualizing the distribution of quantitative variables with many possible values. Unlike bar charts, which are suited for categorical data, histograms group numeric scores into intervals and display how many observations fall within each range. This visualization allows researchers to assess clustering, spread, skewness, and the presence of outliers. In the chapter, the combined depression scale is well suited for a histogram because it spans a wide range of possible scores. Histograms complement numerical summaries by revealing features that single statistics cannot capture. For example, two data sets may share the same mean but differ substantially in shape. By examining histograms alongside measures of central tendency and variation, researchers gain a more complete understanding of their data. The first part of Chapter 2 reinforces a central lesson of research methodology. Careful description must precede explanation. Descriptive statistics allow researchers to understand what their data look like, identify meaningful patterns, and recognize limitations before drawing conclusions. Through frequency tables, measures of central tendency and variation, scales, and visualizations, researchers build an evidence-based foundation for analysis. These tools do not answer causal questions, but they guide inquiry by highlighting relationships and anomalies worthy of further study. This groundwork prepares you for more advanced techniques introduced later, ensuring that explanations are grounded in a clear and accurate understanding of the data. The first part of Chapter 2 reinforces a central lesson of research methodology. Careful description must precede explanation. Descriptive statistics allow researchers to understand what their data look like, identify meaningful patterns, and recognize limitations before drawing conclusions. Through frequency tables, measures of central tendency and variation, scales, and visualizations, researchers build an evidence-based foundation for analysis. These tools do not answer causal questions, but they guide inquiry by highlighting relationships and anomalies worthy of further study. This groundwork prepares you for more advanced techniques introduced later, ensuring that explanations are grounded in a clear and accurate understanding of the data.